Good afternoon, and welcome to the third of 3 videos on section 1.5 in your textbook, analyzing the graphs of functions. We're going to start today in this video where we left off at the end of the second video with average rates of change. This time we're going to do an example that involves kind of a physics problem. All right. The example says the distance s in feet a moving car is from a stoplight is given by the function s equals 20 times t to the 3/2 power. All right. Now remember, in terms of exponents, you're going to cube the value of t and then take the square root of that. All right. That's how the 1/2 is really the same thing as the square root of t. All right, where t is the time in seconds. And we're going to find the average speed of the car from t equals 0 seconds to t equals 4 seconds. Okay, so what this essentially boils down to is this.
It's 6 o'clock.
Thank you, Jesus. The average rate of change is equal to the value of s of 4, all right, the second value of time, minus s of 0 over the quantity 4 minus 0, right? So these are the values of y, these are the values of x. And so what is the value of s of 4? Well, 4 cubed is 64, square root of that is 8. 8 times 20 is 160 minus 0 to the 3/2 power is 0, and 20 times 0 is 0, so that is 0, divided by 4 minus 0, and that leaves me with a value of 160 over 4, which of course is equal to 40. So the average rate of change from time equals 0 to time equals 4 seconds is 40 feet per second. Now, for part B, same, whoopsie daisy, same idea. Come on. S of 9 minus S of 4, which, by the way, we've already calculated, divided by 9 minus 4. So S of 9, well, 9 cubed is, what is 9 cubed? 9 times 9 is 81, and 81 times 9 is 729. Okay, so this becomes 729 minus S of 4, we already calculated, is 160 over 9 minus 4. Well, 729 minus 160 is 569. Oh, come on now. So 569 divided by the value of 9 minus 4, which is 5, and that's going to leave me, actually, that's going to leave me with a number which is, I think I did my math wrong. Let's see. Oh, I didn't take the square root. That's why, dummy. Let's try this again. 9 to the 3rd power, and then take the square root of that. Ugh, come on now. All right, so 9 to the 3rd is 729. Take the square root of that, and I get 27 times 20 is 540. Sorry about that. So this is 540. And 540 minus 160 is going to be 380. All right, so this is 380. And that divided by 5 is going to leave me with 9. No, that can't be right. 380 divided by 5, and that leaves me with 76 as my answer. Okay, 76. And so what that means is that between t equals 4 seconds and t equals 9 seconds, our average speed rather is 76 feet per second. Okay, so that's example number 7. The last thing that we need to talk about in terms of graphs is the concept of symmetry. Okay, and symmetry can occur in several different ways. All right, first, symmetry about the y-axis, symmetry about the x-axis, and symmetry about the origin. Okay, now in this idea, symmetry about the y-axis is the one that you're probably most familiar with. All right, a parabola that passes through the origin like so is symmetrical about the y-axis. All right, you could also draw it up here. All right, as long as it is the same on both sides, that you've got a mirror image around the y-axis, you've got a symmetrical function that is what we call even. Mathematically, it turns out that the value of f of x is equal to the value of f of negative x. So if this is positive 1, and it gives me a value of y, and this is negative 1, it gives me the same value of y. That's what it means. All right, symmetrical about the y-axis. Now, a function that, or a relation that is symmetrical about the x-axis, and I haven't drawn this very well, but notice that it fails the vertical line test. All right, in this case, it hits 2 points on the relation, and so it's not a function at all. Finally, a function that is symmetrical through the origin looks something like this. It's the same on either side. And with this, in this scenario, you've got the idea that f of negative x is equal to the opposite of f of x. Come on now. And so f of x is here, f of negative x is here, and these two terms are opposite one another in terms of their y values. All right, and so f of negative x equals negative f of x. All right, now let's do an algebraic example, because I think that'll help to make it look a little bit more clear. So example number 8. All right, the function g of x equals x cubed minus x is odd because g of negative x equals negative g of x. Now let's prove that. All right, let me change the pen color again, back to red. And so g of x is equal to x cubed minus x. So g of negative x is going to equal negative x cubed minus negative x. Now, negative x cubed is equivalent to negative x cubed minus negative x is plus x. And if you look carefully, this is, damn it. Sorry. This is equal to negative g of x. All right, and I'll show you the picture of this in the next slide. Now, on the other hand, well, actually, screw it. I'll show it to you in this slide. How's that? All right. If you look at this very, very carefully, the blue line represents, or the blue curve represents f of x equals x cubed minus x. And this is symmetrical through the origin, okay? Every point is matched on the other side of the origin. So, for example, if you look at this point here, it's symmetrical with this point here. And this point and this point are, again, symmetrical right through the origin, okay? And this point and this point are symmetrical. I missed that one, but, well, hopefully you get the idea. It's symmetrical through the origin. And if there was something here and wherever, it's all symmetrical through the origin. Now, in this example, and I'm going to go back, h of x equals x squared plus 1. Okay? And so h of negative x is going to equal negative x quantity squared plus 1. But negative x squared is equal to x squared. And so h of negative x is the same as h of x. This makes it an even function because it's symmetrical about the y-axis. And if we draw the graph of this, you'll see that it's actually true. F of x equals x squared plus 1. Okay, and there it is, symmetrical about the x-axis. All right, this point and this point have the same value of y. All right, here's x is 1, x is negative 1. If I do, this is probably x equals 2/5 maybe. All right, but you can see x equals 2/5, x equals negative 2/5, both pass through y equals 2. Okay, and so it's symmetrical about the y-axis. Okay, and so this is even, whereas the one before it here is odd. All right, symmetrical about or through the origin and symmetrical through the y-axis. All right. So that brings us to the end of the third of 3 videos on section 1.5. And so it's time to assign homework. Your homework for next week, next Tuesday, the next class that we have, is to do the homework questions at the end of section 1.5, numbers 1 through 89, odd numbers only. Again, please do your work on a separate sheet of paper, and then take photographs of your work and send them to me via email so that I can have a look at them and see where you might make your mistakes. Remember again that the answer key is at the back of the book. Use that as a guide in order to help you to figure out where you are and whether you're doing the questions correctly or not. All right? So have a great day, and I hope that you learned something.